Hi and welcome to this V-Ray 6 for Maya webinar. I'm Alex Yolov, Product Manager of V-Ray for Maya at Chaos, and I'd like to tell you a bit about this new version of V-Ray. Some of the new features were possible thanks to the research done by our team. We implemented a new thin film layer in the V-Ray material to make the shader more complete. You can use it to shade soap bubbles, or oil spills, and other iridescent effects. We paid close attention to performance, and in this version, the V-Ray environment fog renders up to 30% faster. We made memory optimizations that help bring down memory consumption for scenes with thousands of instances. And of course, all of these changes had to be constantly benchmarked to make sure that we're on the right track. Speaking about performance, we've always wanted to have a way to track render time for each individual shader in scenes, and this is how the V-Ray Profiler was born. You can use it to track the hotspots in your projects and adjust shader settings to render the scenes faster. And we plan to keep building functionality for the Profiler in the future. You can use it with the Memory Tracker to have a complete set of tools for optimizing performance. We also worked with other Chaos teams to build some of the features for this release. Some examples are V-Ray Enmesh, our new procedural geometric tiling utility, the new procedural clouds, or the finite option for the dome light for a better match of 3D objects with IBL images. Finally, I want to talk about USD support in V-Ray. We've improved our material exporter. You can find it under the Tools section of the V-Ray menu. We've made improvements to rendering skeletal animations and OpenVDB caches that come in USD files. This release also adds support for the latest version of the Maya USD plugin. And I have a short demo for you where I'm using the Maya USD plugin and the new Bifrost graph to build USD variants right inside Maya and render them with V-Ray.
I have a Maya scene here, and I've been asked to assemble this robot character. The robot and the different pieces of his gear were exported as USD files. I've loaded and layered the USD files, as you can see in my Bifrost graph, which isn't too different than using the USD layer editor, only I can use the Bifrost graph to create variants. To do this, I'll need to change my graph a bit, basically recreating the same thing but in a different way. The first step would be to create USD references for the contents of each layer. I'll quickly copy and paste the reference nodes and connect them all together. I'll create some new prim definitions, delete the type, and give them some meaningful name. Let me copy and paste the prim definitions. At this point, I'll need to connect all of them in a hierarchy under the same XForm. And I want to create variants where my robot either wears his backpack or has this piece of cloth around his head. Let's define our USD variant set. We can give it a name, and I want to reuse the name since I need to plug it in other places, so I'll just create a value node, give it a string type, copy and paste the name, and I'll need to plug it in the definitions of my backpack and the piece of cloth. We can inspect the outliner and we can see that our variants are already there. We can render out the variants one by one. Here's our backpack variant. And we can switch to the cloth variant and render it out with V-Ray. And that's it. We've created a simple setup where we can switch between variants with different gear for our robot.
I hope you enjoy working with the new features and find improvements that make your workflows easier and faster. I'll turn it over to Boyan Petrov, our CG specialist, who will give you an in-depth look at what's new and improved in V-Ray 6.
Hello, my name is Boyan and I'm a 3D artist at Chaos. In this webinar, I will show you how we're able to achieve the results in the V-Ray 6 for Maya video with the help of our new updates. First of all, the project was very interesting to work on. After establishing the main concept and storyboard, we decided that we'll use the same animation sequence, but the environment will change based on the different V-Ray releases. We took inspiration from Clinton Jones' CG Challenge, where hundreds of artists took an already established animation sequence and added their own twist. This idea was very interesting for us because it meant we had all the creative freedom to explore new environments and concepts. So after the release of the 3ds Max video, we started thinking of what is going to be our next world. We decided we're going to go for the volcanic environment theme. So before we start with the webinar, I just want to give you a quick preview of what we'll cover later on. First, I will show you how we approach the look development stage with the help of the finite dome and the new VFB panorama viewer. Then we'll take a look at how easy it is to export USDs from Maya and import them to any third-party software, where we can continue editing our scene. After creating the environment, we'll fill up the entire interior space of the house with the help of the newly added hundreds of accessories and interior design assets. Then we'll go over some improvements in the V-Ray materials. We'll take a look at some new ways of adding detail with the help of the V-Ray decals and EndMesh. After which I will show you how you can easily create custom clouds specifically for your scene. And we'll finish the webinar with some useful tips about V-Ray 6 for Maya. So buckle up and let's start. In the beginning of this project, we already had our main asset in mind. We wanted to incorporate the incredible concept of Encho into our new release. That gave us our hero object, the most important part in our animation. The next step was to think of the environment, where our mobile house was going to explore. At that stage, most of us started researching different environments for inspiration and imagining if that house is going to fit the area. The best way to test immediately how our assets are going to interact with the environment is to directly place them in 3D space. The quickest way to get a good reference is to add a dome light with an HDRI. Because the house has mobile legs, it can easily traverse to even the toughest of terrains. That's why we decided that the mountain HDRI would fit best. I'll raise the intensity of the dome so we get a proper exposure. When we rotate around the scene, you can notice that the house is floating. The ground seems very distant. To solve this, we'll use the finite dome. We can find this option inside the dome light. When we turn it on, you can immediately see that now the dome light has a size and a position. When we increase the finite radius, we can control the radius of the dome, so higher numbers will push the horizon further away. By increasing the projection height, we can control the scale of the dome light. Notice how the ground resolution increased in size. The ground blend blends between the horizon line and our ground. All these options should be adjusted based on your HDRI. So now the house looks like it's staying on the ground. But does it really? The answer is no, because we're missing the shadows. We don't get any shadows because there is no physical objects to cast shadows onto. The ground of our dome light is just a projection. To get some shadows on our ground, we'll use the V-Ray Shadow Catcher. All we need to do is create a plane and click on this icon. That's it. Now our house looks like it's part of the environment. Next, we have to find the right position of our house. To do so, we can use different composition rules, things like rule of thirds or the golden ratio. In V-Ray 6, we have them built into the VFB. Just by going into the layers, you can find the proportion guide. This is very handy because we can continue rotating our camera until we find the right spot. Something else very useful is the panorama viewer. To enable it, we have to go to the renderable camera and add a camera setting attribute. Then we have to make sure that we are rendering with the spherical camera type, and we'll set the field of view parameter to 360, which will allow us to capture the entire scene in one image. Before we render our image, let's increase the resolution of our render to 10K. That's because we need a big image resolution to create the panorama effect. Finally, in the VFB, we have to enable the panoramic viewer. When our image is rendered, we can use the zoom option with the scroll wheel to properly position our view. Now we can simply use the middle mouse button inside the VFB to rotate around and preview our scene. So far, we explored some new look dev options that will hopefully speed up your pre-production pipeline. Next is the production preparation. What we did next in our project is to visualize the exact environment around our house. We really liked the mountain exterior, but there was something missing. So we decided to add some fire and lava. A lot of fire and lava. But with fire and lava comes simulations of smoke and liquids, something you can do with Phoenix for Maya, but what if your special effect artist isn't native to Maya? You have to export your models, then recreate the shaders and lighting so you can have a representation of your scene in another DCC. Well, we have something that will reduce the time spent on transferring assets significantly. V-Ray 6 supports the latest MayaUSD version and includes new enhancements for OpenVDB volumes and V-Ray material export, promoting an easy exchange with Solaris and other USD pipelines. So let me demonstrate how you can use the USD pipeline. All you need to do is select your group and go to the export setting. There, make sure to select the USD export, and in the options, don't forget to enable the V-Ray plugin configuration and materials. After importing the USD file in Houdini, you can see that it comes with its materials, lights, and geometry hierarchy. This allows you to immediately start adding additional detail without worrying if the shaders and lighting are properly adjusted. In this case, I used Houdini to create some cracks in the windows of our house to add extra ruggedness to the model, indicating that the house has been traveling through some harsh terrain. When we had our environment set, we started the production phase. In this phase, we started thinking about different shots, the lighting, and the specific assets for the shots. In every single shot, we used assets that come from the vast Chaos Cosmos library. In V-Ray 6, we updated our library with hundreds of assets like vegetation, materials, HDRIs, and more. To give you an example of the diversity we have, I will show you how we managed to furnish the entire interior of our house. Just by downloading the asset from here and dragging it inside of our scene, I can position the asset exactly where I want. First, I will place all the furniture so we can block out our primary objects. Next is the vegetation category, where you can find hundreds of diverse trees, plants, and bushes. If you want to search for a specific type of plant, you can use the filters here. You can search by specific tags and even colors. Finally, the accessories, the most important part of creating an interesting interior. If you want to take a closer look at an asset, you can click on it and preview the geometry, as well as the different tags and even the creator of the asset. When we're set and done with the 3D models, we can head over to the material section, where we can find materials like concrete, fabrics, liquids, and others. Right now the floor is looking really dull, so let's spice it up a bit by adding a glass material. I'll just pick one and drag and drop it directly on the asset in my scene. V-Ray will automatically assign it. And there we have it, a furnished interior. Next, I want to show you some material improvements. In V-Ray 6, we also managed to improve the reflectivity in the V-Ray material. By using the new energy compensation update, rough materials and surfaces will look even more realistic. To demonstrate this, I'll use one of the house legs and render one image with V-Ray 5 and one with V-Ray 6. By using the comparison tool, you can notice that there is some difference in the before and after renders. To get an even better comparison, let me show you the difference with these metallic spheres. The energy with the new model is correctly preserved and is most noticeable in the shaders with increased roughness. Note that the new energy preservation model will be automatically added when you create a material with V-Ray 6, but this option will be disabled for older scenes created with V-Ray 5. We do that in order to preserve the original look. Next, I want to show you how we approach the design of our house. You can probably notice that a big portion of the house is actually glass, which on its own is a very boring material. To make glass interesting, we need to use its main functionalities to our advantage. The main properties of glass are reflectivity and refractivity. To make our glass more interesting, we'll use the thin film option, which allows you to create shaders like soap bubbles or oil spills. It does that by offsetting the reflection color based on the surface angle. Let's select our glass mesh and enable the option. You can immediately notice we get some colorful light scattering. Based on a minimum and maximum thickness, you can adjust the thin film to fit your desired look. Note that the maximum thickness only works if you have added a thickness blend map. Let me demonstrate how that works by adding a ramp. If you want the oil spill effect, you can add some noise to it. Sadly, as interesting as the oil spill windows are, it doesn't fit our desired look. So we ended up using this type of color variation. Thanks to the thin film, our windows don't just reflect the environment, but have a tint of their own. Next up was the body of our house. Something we wanted for our house is to be very rough, indicating that it's been functioning for some time. This meant we had to add a lot of little holes for ventilations and some additional detail. One way we can achieve that detail is to add it with Photoshop or any type of texturing software. The problem here is that for each little addition, you have to adjust it in third-party software and export it. In order to not switch constantly between softwares, we used the V-Ray Decal. This is an extremely handy tool that has a lot of potential in different scenarios. Let's create it from here and position it properly, pointing towards the panels of the house. As you can see, the decal is currently displaying a gray color on top of the panel. If we add a black and white mask, we can control the affected area. Just by assigning a displacement texture, you can indent or extrude the texture you have added to any surface. You can control the displacement amount from here. If you want to add a material to your decals, you can simply click on the Create Material button while your decal is still selected. Then I'll add some color and metalness so it matches the surface of the panels. You can put as many decals as you want. When you're done, you can parent them to the body of the house, so when you move it around, they will come with it. Next, I want to present one of my personal favorite utilities added in V-Ray 6, the Enmesh. To use this tool, you will need a pattern of sort, something that is repeatable. A good example for that are textile patterns. At some point in this project, we're concepting to have the house pass through a danger zone. And to visualize that, we wanted to add a broken fence. As you know, wired fences are made of repeatable patterns, something Enmesh can easily recreate. You're probably wondering though, why would we use Enmesh instead of just adding a texture with opacity? We didn't do that because we wanted the fence to be curved, broken, stretched, and most importantly, thick. All these factors will cause our texture to stretch or look very odd in some areas. So let me demonstrate how Enmesh works. All you need to do is select our pattern while holding Shift, select the object we want to spread the pattern to, and click the Enmesh. Note that the UVs of the parent model should be properly unfolded. So if you get some distortions in your Enmesh, you probably should check your UVs. Let's start an interactive render to see what we're working with. As you can see, the pattern is way too big for this fence, so let's adjust the tiling of the pattern from here. When we feel comfortable with the outcome, let's increase the height percentage, which will increase the thickness of the Enmesh. Finally, let's make the pattern intertwine by lowering the crop box. And just like that, our fence is complete. Let me change the pattern with something else, just so we have another version to choose from. At the end of our production phase, we were thinking a lot about lighting. We wanted a dramatic lighting with a lot of cloud coverage, so the lava light is the predominant light source. To block all of the sunlight, we use the new cloud generator inside of the V-Ray Sun. With just a click of a button, you can generate different types of clouds. Higher numbers in the density parameter increase the clouds in our scene. The variety parameter allows you to create patchy or clumped up clouds. And the other very important option is the thickness. By increasing it, we'll make our clouds look very heavy, exactly what we are going for. Before we start rendering our final shots, we should always make sure that every material is optimized so render times will be minimized. To do that, we use the V-Ray Profiler. This handy tool gives you a detailed analysis of how much time V-Ray is spending on rendering different material properties and volumetrics. Let me demonstrate how you can easily check if your scene is properly optimized. Under the Settings menu in the Render Settings, we can find the V-Ray Profiler. Here, you can turn it on and add a location where the .json file will be saved. That's it, so let's click the Render button and give it some time. When our image is rendered, we can open a tab in Google Chrome and add Chrome:/tracing. Here, we can load our .json file, or you can just simply drag and drop it. As you can see, there is a lot of time spent on analyzing the magma ground material. When we select a certain material, on the bottom left, you can see additional information about the process. The specific material corresponds with the ground beneath the house. In the real world, magma is not fully formated rock, so it's in an almost solid state. That's why we used subsurface scattering to add a reddish tint to the whole object. But in this case, it takes too much time to calculate something that doesn't have that much impact. So we have to make some changes and lower down the SSS amount. When we analyze it again, everything looks much better. There is still some SSS happening, but the render time of the material is significantly lower. Following the same steps, you can go ahead and tweak each one of your materials to perfection. After the optimization process, it was time for rendering. We had to render 7 different shots, each one with more than 200 frames, which meant we needed a lot of rendering power. Thankfully, we used the Chaos Cloud rendering service, which allows you to upload your animation sequence to the cloud and all of the frames will be rendered simultaneously, making this time-consuming process faster and easier than ever. All you need to do is upload your scene to the cloud, make sure that your render resolution is properly set, and click Submit. After the animation sequence has been rendered, we use the Chaos Player to get a quick preview of the animation. I'll drag and drop 2 different sequences and align them. If one of your animations sticking out of the timeline, like mine is, you can go to Edit and click on the Resize Timeline. Now we can preview our sequence and add some color corrections. And that's how we managed to create the V-Ray 6 for Maya video. All that was left was the post-processing, to add the final touches. In this project we had input from different people, so we had to organize a way to easily get information about specific shots. As we all know, feedback is one of the most important things when we're working in a team. And thanks to the developers at Chaos, we have the cloud collaboration. You can immediately post the render you have done right from the VFP to the cloud, where you can share the link with clients or teammates. Here, you can create a folder and add different types of variations of your renders. People who have links to the folder can open the images and add comments for further corrections. Let's say you get a comment that the image is too dark. You can quickly go to the VFB and change some color corrections and export a new version. When a new version is added, you can compare them from here. Finally, I just want to mention some quality of life improvements in V-Ray 6 for Maya. First off, we now have light cache in the IPR. So now the output of the V-Ray interactive production render is identical to the production render. In this release, V-Ray GPU has faster light cache and a new device selector that allows you to assign devices to tasks that are available. Well, that was it. I hope you're excited to go ahead and try V-Ray 6 for Maya and achieve great results. That's all from me. Thank you for tuning in.